All right, so I'm going to show you an example problem of how to calculate a colligative property. To do that, we're going to write down, and this could be boiling point, it could be freezing point. I'm going to pick freezing point, but it doesn't really matter. 3.96 grams of sodium chloride which is NaCl are dissolved in 345, we'll say, grams of H2O. Kf equals 1.86 degrees Celsius per moles. So this is the kind of problem that we've got here. To answer this problem, we are going to use that colligative properties equation. I'm trying to make it so that all of that is visible there. So the colligative properties equation we're in is delta T equals K times I times M. And the delta T, right, if it's freezing or boiling, doesn't matter, but you're going to get a different K, right? So all these problems are done essentially the same way. We're going to read the problem. We're going to see we have 3.96 grams of sodium chloride. So I'm going to write that down here, 3.96 grams of sodium chloride. And we have, that was supposed to be a 345, there we go, 345 grams of H2O. That doesn't really match either any of the things that we've written down so far. That's not delta T, that's not K, that's not I, that's not M, that's not molality. But we'll get to that. Some of you may be jumping ahead and saying, I think I see something here. But we do have down here, we have Kf equals 1.86 degrees C per molal. Excuse me, per molal. One thing I can figure out, though, is I can figure out I fairly quickly. I for sodium chloride, all right, because we know water is going to be our solvent, because it says sodium chloride is dissolved in water, so the thing that gets dissolved in is the solute. The thing that's getting dissolved in is the solvent. We can figure out I for that, so we remember sodium chloride is an ionic compound. It breaks apart into sodium and chlorine, or chloride I should say, chlorine ion, and so that's 1, 2, so I is 2 for sodium chloride. So the only thing left here is molals, so I need to be able to figure out molals. So to do that, I'm going to do some factor label, and I have to remember that molals, a molal, I have to remember that because we've been doing that all this week, is moles per kilogram. Furthermore, I know it's moles of solute per kilograms of solvent. So whenever I do this problem, I'm going to look at this problem and I'm going to see that we need moles of sodium chloride per kilograms of H2O. So what goes on top? Well, grams of sodium chloride has to go on top. Grams of water has to go on the bottom because I need sodium chloride on top. 3.96 grams sodium chloride on top. 345 grams of H2O on the bottom. Factor label, I know this is going to be 2 steps. I'm going to start with the top. Grams of sodium chloride goes on the bottom. And we'd like to go to moles, and I better be able to do that. Oh my goodness. Been doing this since fall break, right? 1 goes in front of moles. 58.44 grams goes in front of sodium chloride. And remember, that number comes off of the periodic table of the elements. Gone, gone, and we're left with moles on top. What goes on top of this step is going to be grams of H2O. Why grams of H2O on the top? Because, there it was right there. It's on the bottom over here. It's got to go on the top right here. Kilograms of H2O on the bottom would be nice because that's what we need for our answer. There's 1 kilogram and 1,000 grams, or 1,000 grams of 1 kilogram. Grams of H2O, gone, gone. And we are left with moles on top, kilograms on the bottom. When you plug this number into your calculator, you get 3.96 divided by 345 divided by 58.44. Oh, I forgot to multiply by 1,000. You can do that at any point. And there we go. I get 0.196. I'm going to leave that in my calculator because I'm going to take that and I'm going to plug it into that delta t equation right there. There's that delta t equation. Sorry for marking through it. Delta t equals K. Hey, we have K. There's K right there. 1.86 degrees C per moles times I, which is 2, times, I'm going to draw the 2 coming in over here. There's the 1.86 going in there. Times moles, which is 0.196 moles. I left that in my calculator, so I'm just going to multiply it by 2, multiply it by 1.86, and I get delta t equals 0.74 degrees C. Why is it degrees C? Because moles cancels out. Gone, gone. And the only thing I'm left with is degrees C. That's supposed to be a capital C there. It kind of looks crummy, but you know what? It works for me. Now I got to remember, if it's freezing point, this would be, by the way, this is probably the answer that you'll need for the test. But if the question had asked me what's the new freezing point, which is what it did, then I need to figure out that the freezing point is actually going to be...
Good morning, Beavers. Today is Thursday.
Freezing point starts off at 0, and we have to subtract delta t, which means that our freezing point is actually going to be negative 0.74.
Attention, salute, pledge. Forget to bring...
All right, real quick, I got interrupted by the announcements, but I'm going to go ahead and finish this off. Remember, we subtract delta t because this is freezing point depression. I also noticed an error. I wrote down 4, and I really shouldn't have rounded that 4, so I changed it back to 3 up here. If this was boiling point, remember it's boiling point elevation. So for boiling point, you would add delta t to 100, which is the original boiling point of water. And so that would be boiling point elevation.